Okay, so question 14, we've got two forces and we're told that the resultant, so what you get when you add these two forces together, is parallel to the vector I plus 2j. So when we're trying to find the angle of R, if it's parallel to this vector, it's going to be at the same angle as this vector. So we're just going to find the angle of I plus 2j. So I plus 2j looks like this, 1 across and 2 up. And we want the angle it makes with the vector I. Here's the vector I, so it's this angle here. So to find that angle, we're going to do tan to the minus 1 of opposite over adjacent, so that's 2 over 1. So inverse tan of 2, which is 63.4 degrees. Okay. And it asks for that to the nearest degree. So to the nearest degree, it's 63 degrees. So watch out for that. Part B then. We've got to show this. So we're going to use the fact that the resultant is parallel to this. So the resultant force is going to be those two added together. So in the I direction, I've got 2 and lambda. So that's 2 plus lambda I. And in the j direction, I've got 3 plus mu. Now, because it's parallel to I plus 2j, it's not the same as I plus 2j. It's some multiple of that. So I'm going to say it's k lots of that. So it's in the same ratio, but it could be bigger or it could be smaller than that. And if I multiply that out, okay, so if they're exactly the same, then this, the amount I'm going in the I direction, must be the same. So I can make one equation there. And same in the j direction, that must be the same. And now I've got some simultaneous equations. So this is what k is worth, so I'm going to plonk that into k. So I've got 3 plus mu equals 2 lots of 2 plus lambda, multiply that out. And we're going to move it all that way, to the right. And that's part B done. Okay, part C says, straighten that up a little bit. Given that the direction at F2 is parallel to J, so here's F2. If that's parallel to J, that means the force is going straight up and not at all side to side, which means that the I bit of that has to be 0. So lambda has to be 0, and then we're going to substitute that in and find out what mu is. So we've said that lambda equals 0, and we're trying to find out what mu is, so I've got 0 equals 2 lots of lambda, so 0 minus mu plus 1, so mu is equal to 1. And now I have to go back and find out what R is. So R was the two forces added together, which was this. So that was R. So give me a sec while I rub that out. Okay, so we're going to substitute these in and get our value for R, and then we'll find its magnitude. So R equals 2 plus 0, I, so that's 2I, and 3 plus mu, so that's 4j. Notice that that's a multiple of I plus 2j, reassuring. And then we want to find its magnitude. So 2 across, 4 up. Trying to find the magnitude, which is this length. So we're just going to do Pythagoras. So the magnitude of R is the square root of 2 squared plus 4 squared. So that's root 20, and it asks for that for 3 significant figures. So it's 4.47 newtons.